In this video, we'll talk about objects that are experiencing free fall. In just the first few minutes, you will find out what does it mean for the objects to be in free fall and what implications it has for us when we're solving problems. Then we'll go over quickly over two problems that have to do with free fall, and we'll use the same method that we learned in the previous video for picking the right equation and solving for the unknown variable. Let's start by firstly conceptually discussing what does it mean for the object to be in the free fall. So all objects falling on Earth are experiencing the same acceleration due to gravity. G is equal to negative 9.8 meters per second squared. So any object, no matter its mass, no matter its dimension, has basically the same acceleration if all it's doing is just falling in the air. We should keep that in mind when we're solving the problems. Before I explain this, let me ask you a question, a conceptual question. If I drop a piano and a piece of paper in the vacuum, meaning I remove the influence of the air, right? Because vacuum means an environment that doesn't have air in it. Which one will reach the ground first? Now, everything in you, right, tells you that it should be the piano because it's more massive. However, it's actually neither. Because when we remove the influence of the air, again, all objects will fall with acceleration due to gravity of negative 9.8 meters per second squared. So it doesn't matter that piano has more mass than in this case, than a piece of paper, right? If we take off basically the influence of air friction, they should reach the ground at the same time. You can see a really cool experience of this if you Google or YouTube vacuum chamber, and you can kind of see that if you throw a really heavy ball and a feather, that will actually reach the ground at the first time. Now, let's see what it means for us when solving the problems. Starting with this one. I will still approach this with the same exact method that I did when approaching the problems in the previous video. So I firstly will write down my 5 variables: initial velocity, final, acceleration, time, and displacement. And as I read this problem, I'll start filling it in. A boy drops a quarter from a skyscraper that is 500 meters tall. How long does it take for the quarter to reach the ground? So let's take a look. Let's first deal with the first equation, right? How long it takes. So they're asking for time, right? Since I know it's falling in the air, I can write that acceleration is negative 9.8 meters per second squared right away. That would be a really key point to these problems, just writing down that acceleration is equal to minus 9.8. Okay, 500 meters tall, that's the displacement that it falls. It's going to be negative because it's falling downwards. What else? We need 3 variables in total, remember? So the fact that he drops a quarter means that we can assume that initial velocity is 0 because initially the quarter wouldn't move. Okay, so now we can solve for time. The only thing that's left is picking the right equation. So right now the variable we don't care about is final velocity. So the equation without final velocity is going to be the second one. So based on the variable we don't care about, which in this case final velocity, it's not given and we don't need to find it, we'll pick the second equation. So let's plug everything in here. So delta x displacement is equal to initial velocity times time plus 1/2 at squared. Great. Now, let me find out for time. So initial velocity is 0. Therefore, this term will simply cancel out. Let me rearrange this equation. Let me firstly cancel out 1/2 from both sides. So I will multiply by 2 on both sides. Then I will divide by acceleration on both sides. Since I'm trying to rearrange this equation for t. And now, since I want to get rid of square, the opposite operation of squaring something is taking a square root of both sides. So now I have the final equation that t is equal to square root of this. Plugging in all the variables. By the way, there's nothing wrong with plugging in numbers at this step and then rearranging the equation in terms of numbers. But it's better if I plug in the numbers at the end. So 2 times negative 500 over the acceleration minus 9.8. I find that my time is equal to 10.1 seconds. All right. Now let's take a look at part B. So in part B, now let's say I started with just solving for the final velocity. So the variable I wouldn't care about was time, right? Then if I didn't care about time and I needed to find final velocity, the equation that doesn't have time is this one. So final velocity squared is equal to initial velocity plus 2a delta x. All right, now let me get rid of these equations now that we don't need them. Again, we're looking for final velocity. So all I have to do is just square both sides or square root both sides, right? So that I get rid of the square here and plug in the equations. Again, initial velocity is 0, so that simply cancels out. So it's going to be square root of 2 times negative 9.8 times negative 500. Plugging that in into a calculator, we get final velocity as being 70 meters per second. So as you see, our general approach doesn't really change at all. The only additional thing that I'm adding here is that we automatically know acceleration for our problems. That's pretty much it. But the general equation is the same. Write down, the general approach is the same. Write down the 5 variables here, and based on the variable we don't care about, pick the right equation, plug in the numbers, solve for the unknown. Great. Now let's take a look at the second problem, an apple. So a girl throws an apple. Again, let me write down all of our variables: initial, final velocity, acceleration, time, and displacement. And I will just fill them up as I'm reading the problem. This would, by the way, be a good time to stop the video and attempt this problem on your own piece of paper. Or if not, feel free to keep watching. A girl throws an apple and it reaches a maximum height of 10 meters. With what velocity did she throw the apple? Okay, so they're asking us about the initial velocity, right? So here, notice, again, we always need to have 3 variables, right, to solve for the fourth one. But we're only given one number here, okay? Of course, we need to scan this now for some keywords. So one thing we know that in this unit, if it's falling in the air, the acceleration is negative 9.8 meters per second squared. So we can write that down for any problem that deals with free fall motion. And we need to scan one more keyword, is this one, maximum height. What happens at maximum height, right, is that object will stop for a short moment until it goes back down. So the velocity at the maximum height is 0. Therefore, this velocity is 0, and we got that from the fact that it's at maximum height. Okay, now we have 3 variables, and we can solve for the fourth one. Right now, the variable I don't care about is time. So let me pull up the equations. The equation that doesn't have time in it will be the third one. So final velocity squared is equal to initial velocity squared plus 2a delta x. So let me plug all the variables in. So final velocity is 0. Initial velocity is the unknown. Acceleration is negative 9.8. And delta x is 10. Now, if I just rearrange this equation and put 2 times 9.8 times 10 on the left-hand side and take a square root of it to cancel out the square, look, maybe that was too fast. So since this is minus, right, I add these variables on the left-hand side. Then I take a square root and I plug this part in my calculator to get that the initial velocity is equal to 14 meters per second. Always remember to put the units, and almost any number in physics has some sort of unit with it. Okay, now let's take a look at the second problem. So they're asking us about time now. So let's say now that we know the initial velocity, we can basically use any equation to solve for the time. For example, this second one. So final velocity is equal to initial plus AT. Let's plug everything in here and solve for time. So final velocity is 0. Initial velocity is 14 meters per second. Time is negative 9.8 t. I will firstly subtract 14 from both sides and then divide by negative 9.8 to find that my time is equal to 1.43 seconds. So I just want to emphasize, right, that in general, our approach for freefall problems did not change at all. Our general steps will always be the same. I firstly write down my 5 variables. I look at what numbers are given, but I also keep an eye on any kind of keywords, right? This acceleration is something I can write for all my freefall problems, and then I might also need to identify some keywords. Once I have my given, I can think of what variable I don't care about, right? And identify one of those 4 equations. Once I identify the right equation, it's really simple. I just plug in all the numbers and solve for the unknown. So hopefully this all made sense. Guys, keep studying, keep practicing these problems, and I promise you will conquer physics this year. This year is yours. Thank you for watching as always.